Alright, so we're going to look at chords and arcs, and so we start with some definition of, we have a chord, which is just any 2 points within a circle in the line segment that connects them. So we have a chord, PQ, that's the line segment, and then we have an arc formed by P and Q, which is part of the circle. And we have some properties down here that we can talk about. So within a circle or in congruent circles, congruent central angles have congruent chords have congruent arcs, and congruent arcs have congruent center angles. What that really means is that if we have the same length here and another congruent segment over there, that the arcs that they create are going to be the same. And so we'll look at an example down here. Those arcs are going to be congruent. We've been given that this is bisecting, so those are congruent central angles. This is the same, so we could show it with side angle side, but basically we get to these arcs have the same measure, and they're going to be the same length as we go through. This is another couple properties that we have chords are equidistant from the center that are congruent. That means if the distance from the center is the same, the chord's the same. And then congruent chords are equidistant from the center. So that's the converse of those two things. So this is often what this will look like. Here's the distance to the center. That's a 4. That's a 4. What that means is these two distances, QS and AB, are going to be the same. So this one is 7 and 7, which means this one also has to be 7 and 7, or 14. So when those two are the same, that means those chords are the same, which means that has to be 14. So not too bad. Right? And if we draw some circles in a diameter that's perpendicular to the chord, then it bisects the chords and the arcs. That means that it's going to cut it in two. And then it goes the other way around. If it bisects the chord, then it's perpendicular. And then if you have two chords and bisect them, you get the center of the circle where they cross. So that's this first one. If I draw that diameter, that's perpendicular, and so it cuts it into two equal pieces, so like 3 and 3. Now, if we go the other way around, it would work as well. And if we had another chord up here and bisected it, they would cross at that center point. All right. So here's an example at the bottom. We have circle R, P and Q are points on it. So we'll put those points on there, and we will draw that distance. All right. The distance from R to PQ is 15, and PQ is 16. Find the radius. So what this looks like is that's 16. That's 15, and we're looking for the radius. Now, since it's perpendicular, that 16 gets cut into 8 and 8, and that's my radius. So we built a right triangle again, where I'm going to use the Pythagorean theorem, a squared, b squared, c squared, to set this up, and I'm going to figure out that r squared is 64 plus 225, and I get 17. So the radius of that circle is 17 with those properties.